Okay, so I want to take some time to actually go through the Stratum portal and show you how easy it is to deploy an application on Stratum. So we're going to create a very basic app, write it in Python, and we'll put it up on Stratum, send it a job, and see what the response looks like. So let's get started. So this is the Stratum portal. I'm logged in with my user account here. I just created this team for demos. As you can see, it comes with a sandbox workspace by default. It doesn't really have anything else. And we're going to get started by clicking on Deploy App. Okay. So as you can see, there are three ways to deploy apps, and there are two different kinds of apps that you can put on Stratum. The first is a Stratum Task, which is essentially just a function, really. You can write it in whatever language you want, use whatever framework, and as long as it can be containerized, it will run on Stratum. So we're going to use Python for this example. Just do it on a base Ubuntu image, and we'll write a very basic function. So how Stratum tasks work is that when you send a request to the API, it creates a request.json file with your input body, the JSON request body. Your function needs to read that file, do whatever processing you need, and then write another file called response.json in the same location. Stratum will take that and then respond with that for your job result. The other kind of task is a web app. This is basically any container that serves over HTTP or HTTPS. Websites, React apps, APIs, anything like that, where you have a pre-built container, you just want to deploy it and start communicating with it. That's what a web app's for. Right now, we'll go with the Stratum task just to keep things simple. So let's click on that. Okay, so this goes through some documentation here which tells you how to install the Stratum CLI. So when you work with Stratum tasks, everything that you're going to do to deploy and modify is going to be with the CLI. There are obviously certain things you can do with the portal as well, and I'll show you that in a second. So let's go ahead and install the CLI with these commands. I'm going to go in to my favorite editor, add this, so update and install. Okay, I already have the latest version of it, but it'll take a couple seconds longer to install. Okay, so once you do that, you start by logging in, but you want to do this from inside your project directory. So let's create our project directory. I'll call it Stratum Demo Fibonacci. So we'll create a file. This is where all your source code is going to be. You can have whatever you want in here, use whatever framework, like I said, and Stratum will work with it. So like I said, Stratum tasks work by first reading a request file. So let's read request data. So we're just going to open the request file and we'll do that. Okay, and then we do some kind of processing. The function will do, and let's say we create a value here and we'll call it 0 for now, and finally write the output results. So let's put it in a variable called value like that. Okay, so if this is really all you need to interface your application code, your complex algorithm, whatever it is, with Stratum, and then you just really put your function in here. So I'm going to copy a function that I found online that calculates the nth Fibonacci number in a sequence. So obviously the details don't matter right now, but the Fibonacci sequence is a sequence where any number of the sequence is a sum of the two previous numbers in that sequence. So it starts with 0 and then it goes to 1. These two don't work because there's nothing before that, but then the next digit is 1 because 1 plus 0 is 1. The next one is 2, 3, 5, 8, and so on. 0 is sometimes considered the 0th digit. It's not really the first digit, but we'll go with that. Now, this is actually a horribly inefficient method to implement the Fibonacci sequence. Recursion's really cool, but when you're calling the same function for n-1 and n-2 in the same call, that's really inefficient because you're running the same computations twice. There are methods with space optimization and dynamic programming where you can do this a lot more effectively. But for the purpose of this video, we're going to go with this. And if anything, we actually want something that's not very efficient so we can really strain the system and see how Stratum responds to that. Okay, so we need the value here, so let's just do this. So we'll do value equals Fibonacci, and let's put the request in a variable called n inside the JSON file. Okay, so we have this function, and what I'm going to do is I'm going to create a request.json file. Let's make sure it's in here, and we will put in the request n. Let's calculate these 6 digits. So that should be 1, 1, 2, 3, 5, 8. So we're just going to cd into our project directory, run the Python main file, and this goes through and generates a response with the value 8. Okay, let's try another number. Let's try to calculate the 20th number in the Fibonacci sequence. So we'll call that. You go to the response, and where you go, you already have a pretty big number. And if I go to 30, this is going to start taking longer and longer to process. The numbers get bigger. This is going to be fun. You can see, you can hear my CPU, like my computer fans, going up because it's trying to do this. This is such an inefficient way of calculating it, but you know, it's great for this purpose. There we go. And there's a number. Okay, so there we go. So we've created our function. Let's see, how do we put this on Stratum? You start by logging in to your Stratum account, so let's do that. Okay, once you log in, so if this is the first time you're working with your task, you need to initialize it. So you initialize it with the command -s. Just so you know, you can just type in Stratum over here, and it's going to print out all the possible commands you can run. And if you type a command, so let's try init because we're going to use that, and put -h after that, it's going to give you specific help, like instructions and usage for that. So we're going to do is initialize this as a Stratum task, and we'll call it just Stratum Demo Fibonacci. Okay, we're going to go to the demos team. Okay, so Stratum is our task is created, and it generated this stratum.yaml file. I'm going to delete these 2 files because we don't need those. And in here, okay, so this is what you're going to call the task. Let's just call the bad Fibonacci calculator. Let's just keep the Ubuntu base image. This is essentially the container image you're going to start off of. Okay, so the list here is going to be a set of commands, a script essentially that you're going to run to build your application. So like if your app was built in C++, for instance, you need to compile it, or Golang, you need to compile that and create an executable. So that's where you use build for. Now, because we're doing this in Python and that it's a scripting language, we could, if we wanted, convert this to a Python executable, but we're just going to use deps and set up the dependencies for the install and go with that. So when we're doing apt update, apt upgrade, we use the -y so that it's a non-interactive screen. Let's install Python 3.8, and we'll just we'll call Python 3.8 main.py to actually run it. We'll put a timeout for 1 minute, so if we're sending it a task that's trying to take longer than a minute, it's just going to time out instead of keeping the container up. We'll leave these over there, min workers to 0, max workers to 8. That's fine, and we'll see how that goes. Okay, so once you configure your YAML file, you do stratum push to sync that to the cloud, and then stratum build to run the build. So you could use the --deploy or -d option. We'll just do that, keep it simple, to deploy the app as soon as it's built. So this is going to compile all the files you have, make a zip file, send it to Stratum, and this will give you a link that you can use to track your build progress. Okay, so there we go. It's building the image now. This can take a minute or two, so I might just fast forward on this. Okay, so it looks like that built, that took about 3 minutes to go through. This is essentially, as you can see, this is your dep script. What Stratum does is just creates a build script for you, a Docker file essentially, and then runs it to build your container, and then deploys your container, does all the networking that's needed to set everything up so that your app is actually deployed. So that's what happens in the 3 minutes over here. I just say, once you have your app that's built or you make some changes, run the build command, go get a cup of coffee, and come back, and it's good to go. So let's go over here. All right, so we have the app up. You see all of the numbers are 0 here. Now workers is also 0, so there's nothing up right now. So if you go to, you can set up environment variables here if you want for your app. You can configure auto scaling. This is if any workers are up, you can actually see the console or SSH into the individual workers, and you can set up any API keys that you want. So for now, to prevent others from accessing our app, let's go ahead and set up API keys. So we're going to require app users to use an API key to send jobs. We'll create a key. It gives a name for it. We'll click on that to copy it, but we might come back here for that. But that's it. And then make sure you hit the save button over that comes up over here to confirm your changes. All right. So your app is up on Stratum. Let's go to Insomnia, which is essentially like an API tester thing that you use. And we're going to create a new request, and let's call this Fibonacci QJob. So this is going to be a post request with a JSON body. I'm going to put this here for now. I'll come back to that. Let's go here to our app. Guess you can see it's live. So how this works is you have a dispatch URL here, a task URL that has your task code, and it's .stratumapp.io, and you send your jobs to that request. It's a post request that you make with JSON input as your request. So we're going to go here, and just like we did, we're going to put n, and we're going to give it 6 to start off. Now, because our app is protected, because we have API authentication on there with a security key, you need to have this variable xstratum auth, and you need to pass the API key there. So you would add a header with that, and your API key goes in there. So let's go ahead and hit send, and there you go. So we have we got a 201 saying that it created the job and it returned the job ID. So we're going to, can you duplicate this? Yes. So we're going to do Fibonacci get result. So this is going to be a get request to the job ID that you get from your queue. And obviously you don't need anything here. You still need your headers. And if you look at that, we have our result. So this is the entire job object that we get back. That includes the status. There's the input. There's the result where you see the value is 8. You have your STD out or STD error, any errors if there are any. You have your queue time, start time, end time, metrics on how many CPU cores you used, and the time sample. So this entire thing happened very quickly, so it's it barely used anything. So if we go in here and go to debugging, we have one worker up right now because this just processed a job. So if I click on console, you can see that here it's processed and completed. Let's just send it another job. I'm going to send that. So it sent it, it queued it. Okay, it's already done, and it already gave the response. So if I put this new job ID in here, yeah, you'd have the response. That happened in about 300 milliseconds. So it's pretty fast with this. Let's mess around with this a little bit. Let's see. I can do this, right? Yes. Repeat on interval, and let's say we'll give it. You know what? Actually, here's what I'm going to do. I'm going to go to JSON. I'm going to make this 40 because we know that takes decent amount of time. And we'll do repeat on interval, and let's send one every second. 1, 2, 3. All right, Okay, that's good. All right, so we sent a bunch of jobs over here. Let's see what's happening. So it's processing one, it's taking some time, and over time, once it recognizes that it's going to take some time to process this job, it's going to scale up some more workers. So we just completed the last one. We're not going to. So actually, let's get the job ID from the last one over here. Got to get it. Let's put that. Send now. Okay, as you can see, this is still queued. It's still working on it. It has its input. There's no result. Okay. Now Stratum just scaled this up to 8 workers because of the request rate that we were sending it. And how long it's taking to process these tasks. It sees that it really needs to scale up very quickly to handle that workload. And now these are, as you can see, some of them are in idle because they're not processing anything, but the other ones they're still processing their jobs. So let's go back here. Let's do another. Okay, so this one is actually processing right now. So that's probably one of the actives. Okay, we have most of them going back to idle. There we go. So it's done. Another interesting thing is here in metrics, you can see that it has a timestamp for each. So this is broken up into intervals, and it shows you the CPU and RAM usage over time. The RAM is in megabytes and CPU is in cores, and it shows how that goes over time. So Stratum scaled up the application to handle the demand, ran these jobs, and sent the responses, and then we just deployed the app. Now here's the really cool thing. In about 2 days, it's usually mostly responsive for the first 48 hours, but after that, it's going to start learning your usage patterns. It's going to look at what your request rate looks like, what your CPU and RAM usage looks like, and it's going to identify patterns in that, and it's going to start predictively scaling for you. So right now, when we sent it, about 8 or 9 jobs at a time, it needed about 20 to 30 seconds to realize that you're getting a huge rate, and it's taking a lot longer to process, so you need more workers for that. But with after 2 days, it's going to predictively scale on its own based on these usage cycles, and it's going to learn patterns like what kind of request rates do you have on weekdays? Which weekday? How about a Saturday evening? What about when there's a big event happening? So there's a lot of interesting things that Stratum can do with this and its backend AI model to predictively scale and manage your cloud infrastructure. Well, that was I want to kind of wrap up the video over there. I know we talked about a good amount. I showed you essentially how to build your app, put it on Stratum. If you're a developer, a dev shop, or a SaaS software provider, let me know and I can give you private beta access to the Stratum portal. I'll get you an account set up so you can start playing with it for yourself and see how it saves your company not just cost on your cloud deployments, but more importantly, the DevOps time with how easy it is to really get something up and deploy it on Stratum.